Okay, let me give you a couple more example about improper integral, okay? So by the definition of improper integral, it is equal to integral 1 to a 1 over t dt, right? And we're going to send your a to infinite, okay? Which is equal to limit a goes to infinite. And do you remember this one? Antiderivative of 1 over t is special thing, right? Which is natural law, right? Here we go. So ln t, and we're going to plug in 1 and a. Is it okay? So we assume a is bigger than t, right? Definitely is positive number. So we don't have to worry about absolute value anymore. It is equal to limit a goes to infinite ln of a minus ln of 1, okay? But as you know, ln 1 equal to 0. Then when you plug in infinite, that is just equal to infinite, right? So it's diverse, okay? So what about number 3? Same thing, right? But like this is more general case, right? When p equal to 1, that's exactly the same with the example 2, then we're going to take it like the other case as well. So by definition, it is equal to integral 1 to a t to the minus p dt, and we're going to send your a to infinite, right? So case by case, case 1, when p is equal to 1, then it is integral 1 to infinite t to the minus 1 dt. We took care of this already in example 2, right? Then let's talk about the other case. When p is not equal to 1, which means your function is exactly power function, then we can use the power rule, right? Then integral 1 to infinity t to the minus p dt is equal to integral 1 to a t to the minus p dt, and send your a to infinite, right? By the power rule is equal to limit a goes to infinite, and that one is 1 over minus p plus 1 t to the minus p plus 1, and plug in 1 and a, okay? That is equal to, let me write the coefficient first, because there is no a term, so it can be written in front of your limit. It might be much easier calculation. Then plug in a, then it is a to the minus p plus 1, and minus 1 to the minus p plus 1, which is equal to 1, right? Let me rewrite this one. 1 over minus p plus 1, and then limit a goes to infinite, a to the minus p plus 1 and minus 1, okay? So think about it. When a goes to infinite, okay, if your exponent part is negative, okay, I mean negative p plus 1 is negative, then infinite to the negative, which means 1 over infinite, that is equal to 0, okay? So let's start from there, okay? If your exponent, which is minus p plus 1, is negative, okay, then what happened? Integral 1 to infinite t to the minus p dt is equal to 1 over minus p plus 1 times negative 1, right? You understand what I'm saying? When like this was negative and this exponent is negative value, then infinite to the negative 1 is 1 over infinite, which is equal to 0. That's why we don't have like that part, okay? And that is equal to 1 over p minus 1, right? But the other case, definitely diverge, okay? Okay, so we don't care about, we are not interested in like diverse case, okay?